So at first today we will discuss about the difference between strata and clusters. Okay, so what is strata and what is cluster? So strata and clusters both are non-overlapping subsets of the populations. They differ in several ways. All strata are represented in the sample, but only a subset of cluster are in the sample. So strata means what? Strata means in that strata all the samples can be there. Okay, all the values can be there. But when we are saying about cluster means what? Here we are doing the subset of the sample. So subset of clusters are in the sample. Okay, so that is the difference. That means strata can have all the datas. All that means all. Suppose we have a whole populations, and from the whole populations we are stratified the populations. But all the datas can be there. But when we are clustering the data, so some datas cannot be there. We are taking some subset of those data. Okay, so that is the thing. Just a minute, So the strata and the clusters both are non-overlapping subsets. Okay, so with stratified sampling, the best survey results occur when the elements within strata are internally homogeneous. That means we are getting the same type of data. Okay, so that is the best survey results when the data's quality, data's categories are same. But with cluster sampling, the best results occur when elements within the clusters are internally heterogeneous. Okay, so in that clusters we have heterogeneous data also. So when in strata, when the data are homogeneous, that is the best survey results, and in case of cluster sampling, when we have heterogeneous data, that is the best sampling. We are getting the best results. So these are the difference between strata and clusters. So now we will discuss about multi-stage sampling. So multi-stage, okay, that means the sampling can be done with different stages, different steps can be there. So this is the complex form of cluster sampling. So obviously this is very complex form because we need to take the samples of the populations with different stages, different levels are there. Okay, so in which two or more levels of units are embedded on one in the other. So first stage we will do some random number of districts chosen in all states. Suppose we are getting the project that we have to sample the states. So at first we will sample the districts of states. So at first we will take the random numbers of districts chosen in all states are there, and we will choose the random number of districts from that, and followed by this random number of then we should choose some taluks or villages. So under this district some villages can be there, some taluks can be there, so we can choose that. And thirdly we can choose some houses, we will select some houses. So that means we are taking the broad area. Okay, that is we are choosing randomly some district, and inside the district how many villages are there or how many taluks are there, we need to choose that randomly, and after that we need to choose the houses. Okay, so all ultimate units, houses for instance selected at last step are surveyed. So actually we need to survey for the means we need to select the houses, and we need to take the informations from the persons who are present inside the house. Okay, so we should take the informations from them. So ultimately our purpose is that, but before that we are sampling the districts, and after district sampling we will sample the villages or taluks, then we can go for the houses. Okay, so these are the multiple stage sampling. So different stages are there. So this technique is essentially the process of taking random samples of preceding random samples of preceding random samples. That means we are taking some random samples and again we are doing the random samples on those random samples also. Okay, so that is sample of samples, right? So that's why this is called multi-stage. So not as effective as true random sample, but probably solves more of the problems inherent to random samples. So it can solve different types of problems of random samples, and an effective strategy because it banks on multiple randomizations. Okay, so it is extremely useful. So here we are doing multiple multi-stage sampling. So we are sampling the data again and again. So that means we are getting the perfect data what we need. And multi-stage sampling used frequently when a complete list of all members of the populations not exist and is inappropriate. Okay, so this sampling it can use frequently, and the complete list of all members of the populations not exist here because we are sampling again and again. So it may be sometimes inappropriate also. So by avoiding the use of all sample units in all selected clusters, multi-stage sampling avoids the large and perhaps the unnecessary cost associated with traditional clustering sampling. So this is the advantage of multi-stage sampling. So here we can avoid the large and unnecessary datas. Okay, and this is if we can avoid different unnecessary data, so it is obviously cost effective. So different so we can do our sample in our budget. Okay, so it is a low budget sampling because we can cost the budgets, we can cost the sampling cost of the huge data, because here we are reducing so many values, so many datas. Okay, so it is the advantage of multi-stage sampling over cluster sampling. So another point is part of the information is collected from whole sample and part of the subsamples. So here this is actually multi-phase. So in multi-phase, where we can collect the whole sample, informations from the whole sample and also from part of the subsample. Okay, so we are getting the data from different phases. At phase 1 we are getting suppose the whole sample. At phase 2 we are getting the different we are just a subsample of we are getting the subsample of the whole sample. Okay, and this is multi-stage. Okay, so these are the, you have to remember the difference between these different types of sample, that multi-stage and multi-phase. Okay, cluster sampling, what are the differences between these? So here we have suppose we are doing some survey. Okay, and here we are doing some suppose medical survey. So here we are doing at the phase 1 we are getting some different types of access. Suppose this is a TB survey and this is MT surveys, and we are X-ray chest in MT plus this is the positive cases. Okay, in the phase 2 we are getting these values, the positive values, the X-ray reports of the positive X-ray reports, and then sputum examinations is X-ray. These are the positive cases. So that means suppose this is actually the medical survey. So here we have the the lots of data, lots of criteria for a patient, and we at the phase 1 we need to take some different criteria, and the phase 2 just we need to take again from that criteria we need to just resample those data. So, we need to take only the positive cases, and here also we need to cases the sputum examinations we need to cases the positive cases. So, different phase we need to sample the data into different phases. Okay. And survey by such procedure is less costly, less laborious, and more purposeful. Okay. So, this is also very important sampling technique, because this is also less costly sampling technique, and this is less laborious. You can do it without much more effort and more purposeful, and it can solve your purpose very clearly. That means the actual data, the perfect data you can get from the whole sample, from the whole data, whole population. Okay. So, another sampling technique, that is matched random sampling. So, matched random sampling is what? Here a method of assigning participants to groups in which pairs of participants are first matched on some characteristics and then individually assigned randomly to groups. So, that means there are some criteria. In matched random sampling means here we have some criteria, we have some conditions. If the persons of the participants are matched with that means criteria, then they are selected. Okay. And the procedure for matched random sampling can be briefed with following contexts. So, here two samples in which the members are clearly paired or they are matched explicitly by the researcher. Okay. For example, you can say IQ measurement of pairs of identical twins. Okay. So, two samples in which the members are clearly paired. So, if you are just measured the IQ of the twins, so that is the you are taking the samples from the paired. Okay. And those samples in which the same attribute or variable is measured twice on each subject under different circumstances, commonly called repeated measures. Okay. So, in matched random samples, you need to know, you need to do the samples on some identical pair, or you need to do the samples in which the same attribute or variable, you can do that on some same variables or attribute, and this is measured twice on each subject. So, that is repeated measures. Okay. But the circumstances are different circumstances. Okay. The surroundings are different, but the pairs are same. Okay. So, this is called repeated measures. So, this is the example. Here the example includes the times of group of athletes for 1500 meter before and after the week of special training, the milk yields of cows before and after being fed a particular diet. So, that means we are selecting a group. Okay. Before means before training and after training. Okay. So, this type of things means before training there are, you can select some athletes, and after providing the training and after training means there are lots of means effort, and this lots of things can be there, and after that you are getting those persons. Okay. And this is also examples of means matched random sampling. And another things, suppose another example is milk yields of cows before and after being fed a particular diet. So, means when you are getting the milk from the cows before diet and after diet, you are getting, you can get the variations. So, the situations is different, but your sample value is same, your means your populations is same, but the circumstances are different. Okay. So, you are providing the training, before training you are getting some athletes, and from that athletes you are selecting some athletes. Okay. After training. Okay. So, that means your assets are same, but the surroundings are different. Okay. So, this is called, this is the example, these are the example of matched random sampling.